Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Okay, uh, today is our first class for my part, EBB 344 Mechanical Metallurgy. Okay, for the first topic, I will touch about the tensile test. Okay, I think maybe some of you have seen this kind of testing, and maybe some of you didn't yet. Okay, so in this particular topic, okay, I will show you one videos, okay, in order to show how the tensile test has been used in the real engineering world. Okay, you need to watch this video. Okay, this video I will share with you later. Okay, even I will share with you the slide in the e-learning portal. Okay, here is the example how the tensile test has been applied. Okay, in this particular engineering application, okay, they use the steel wire cable, okay, in order to tighten, okay, in order to tighten the bridge. Okay, for example, kalau you tengok dekat first bridge kan, ataupun second bridge, kamu akan tengok at the middle part of the bridge tu dia akan pasang install wire. Okay, wire tu has been used in order to hold the structure of the bridge. Okay, normally how the tensile exists or presence in that particular steel cable. Okay, when you pull, okay, let's say for example, when you pull like this, okay, the tensile will be formed inside that steel cable. Okay, in this case, they try to tighten, okay, the cable car wire by using something like clamping. You can see here, okay, when they clamp, so nanti dia punya steel wire akan jadi very tense, okay, and very tight. So nanti you boleh tengok this video. I will share with you the slides later in the e-learning. Okay, so that's about introduction about the tensile test. Okay, in simple word, the tensile test something like you pull in opposite direction. For example, kalau you ada macam satu getah pipe, okay, or rubber wire, whatever, you try to pull like this in opposite direction, so the tensor will be formed uh, in opposite direction, and then they will form something like the tense wire when you pull in opposite direction. Okay, so okay, here is another video. Okay, I think maybe the audio for this video, I think you can hear. I'm not sure why, but later no problem. Later you can go through to my slides, and then you can watch this video again. But I want to explain how the tensile test works. Okay, you need to watch this video carefully. Okay, there have a few stages involved in order to check that particular metal works or metal piece or metal structures, okay, is failed due to the tensile performance. Okay, and then you can see if the material is brittle, how the fracture surface looks like. If the material is ductile, how the fractures looks like. And if the material is semi-solid, is how the structure looks like. Okay, please watch this video carefully. Okay, here is the example of the uh, testing. Okay, this one, the how I say, the instruments or machine that we use for the tensile test. Okay, I think we have this instrument in our laboratory, in ISO lab, as well in the polymer lab. Okay, for tensile test, as you can see here, there have a standard specimen shape and size. Okay, in order to measure the tensile test, the sample, normally we use the metal, the rod shape sample. Okay, this one, how the sample is set inside the machine. Okay, you can see they put the sample. Okay, you can see the sample holder. So meaning that, okay, the sample, as I mentioned, the sample will pull in opposite direction. Okay, in this case, this ultimate tensile machine, okay, will pull the sample. Okay, in this particular tensile test, the elongation of the metal during the tensile test performance is very crucial. So normally the graph plot after the test, normally you can see stress over strain. Okay, in tensile test, okay, as you can see here, uh, this one we call as a stress strain graph. Okay, normally in the y-axis we refer to the stress, and then in the x-axis we refer as a strain axis. Okay, in this stress strain curve, there is a lot of information you can get only from the single measurement. Okay, in the latter part I will explain to you in details. Okay, so I'll move forward a little bit this video. Okay, so now you can see uh, when the machine start to pull the sample, okay, they will capture the reading for that measurement. Okay, you can see the graph increase and then suddenly drop and then stable back, and then you can see the sample is fall down. Okay, the graph is fall down. Okay, each stages of this graph is very important information. From this graph you can understand whether that metal is elastic, plastic, or it's easy to fracture or not. Alright, so this one the measurement, nanti you will tengok this video. Okay, there are a lot of interpretation. Okay, these are very important. Okay, I go back at the big again. Okay, as I mentioned, okay, this stress strain curve, the sample will pull in opposite direction over the time. Okay, when the sample reach that we call as a yield point. Okay, when the metal reach the yield point or ultimate tensile strength. Okay, not yield point, actually the ultimate tensile strength is the maximum value of the stress over strain in that particular. Okay, as you can see, when the sample is failed, you can see the neck exists when at the surface of the fracture area. Okay, and this video you can watch later. I don't plan to explain to you too much on this. Okay, okay, this one is very important. Okay, all right, I show you this. Okay, let's say this from the naked eyes. Okay, you can see. Okay, if when you do the tensile test measurement and then you found the surface fracture area and shape something like the cone shape type. Okay, something like this we call cone shape type. Okay, and then the flat, and then the sample is like something like this. I can see something like the woman body, the shaping. Okay, and macam pinggang perempuan, you can shaping. Okay, and then this sample broke into two. Okay, when you see this kind of shapes after the tensile test measurement, okay, we can easily identify, okay, this metal is the ductile, because the ductile properties is they tend to elongate. Okay, they tend to elongate before fracture. That's why we call as a ductile material or ductile metal. Let's say if the sample is brittle, something like ceramics, normal ceramics are brittle. Okay, when you pull, okay, it automatically breaks into two without elongation. Okay, without elongation. Jadi what happened to the semi-solid? Semi-solid, maybe you can find certain surface is very flat, certain surface is still in the cone shape. Okay, you need to go through all this video back. Okay, sebab duration roughly about 8 minutes. Okay, you can see here. Okay, how the machine looks like. Okay, all right. Okay, now here is setup. I think I already mentioned to you. This one example, the old machine of the tensile ultimate tensile machine. Okay, this one how they hold the samples. Okay, how they hold the samples. So in this case, as I mentioned, for tensile test, there is a standard we call, so either we follow the American Standard Testing Method (ASTM), or Japanese international standard, GIS, or other kind of standards set by the standard commission of a certain region or certain countries. Okay, in this particular case, as you can see, this shape of specimen we call it as a dumbbell shaped specimens. Okay, here I want to explain to you. I need to take a little bit time to explain about this. Okay, why I put star here? Okay, I put star here meaning that this graph is really important. Okay, I think when you learn EBB 113 in the first year, I think you already exposed this kind of stress strain curve. Okay, don't confuse because later part, okay, in this topic you will find many type of graph, okay, and their function also different. Okay, this graph dedicatedly used for the tensile test. Okay, remember in your mind, how I say, how I say, implant in your mind when we talk about the tensile test. Okay, the first graph cross in your mind is the stress strain curve or the stress strain diagram. Okay, here I give you few tips in order to understand this graph. Number one, you need to understand how to draw, how to sketch. Okay, the ideal shape of the stress strain curve. What is the meaning of the ideal shape? Okay, this curve, you need to see my mouse here. Okay, this curve, okay, I mean this curve shape, okay, we call it as an ideal case of the stress strain curve graph. Okay, for the stress strain graph, graph, the y-axis refer to the stress and x-axis refer to the strain. I think the stress of how to get the stress, how to get the strain, I think is easy to calculate by using the formula. Okay, what I want to touch in this part is, as I mentioned earlier, okay, in this stress strain curve, we have a three stages. Okay, we have three stages. Okay, number one, uh, when you do the tensile test, okay, as you can see in the first video, okay, we will pull the metal rod, right, or metal dumbbell shape sample. Okay, when we pull in opposite direction, okay, the measurement will read the stress and strain constantly increase. Okay, constantly increase. Okay, meaning that if you pull, okay, the reading is increased, so you know already at initial stage this metal is a ductile type metal. Okay, when you pull and then this reading will increase gradually until this measurement reach the yield point. Okay, what is the meaning of yield point or yield strength? I think in the next slide I give some information you need to read about it. Okay, once, if, well, let's say you pull more, okay, you continue pull the specimens and then the reading exceed the yield strength or yield point, okay, this graph will tend to increase and then suddenly constant until it reach the maximum peak of the graph. Okay, in this, from point 2 to point 3, okay, the process of the increasing, we call as a strain hardening phenomena. What is the strain hardening phenomena? I will explain later in the next slide. Okay, when the reading is constantly increased until it reach the peak of the graph, we call as a ultimate tensile strength value or UTS value. And then again, when we continue to pull the sample exceed the UTS point, okay, at this stage, okay, the fracture mechanism, I repeat again, will start to initiate. Okay, what is the fracture mechanism. Okay, later I will explain in the next video. Okay, and then from point 3 to point 5, okay, uh, there is what we call as a necking phenomena. Okay, what is the necking phenomena? Okay, the necking phenomena, I think I show you in this slide. Okay, in this video. Okay, in this video, okay, here you can see something like necking. Okay, we pull and then until we get this necking. Okay, and then in this region we call as a necking process, meaning that the necking process is not failed yet. Okay, when you pull exceed the UTS point, okay, the how to say, the void start to form, and then this void will increase the size and then the propagation of the void, and then until it breaks. And then the fifth point we call as a fracture condition, meaning that the metal rod or the dumbbell shaped metal rod, the dumbbell shaped metal already broke into two. Okay, what are the information that we can obtain uh, in this stress strain curve? Okay, number one, as I mentioned, if you do the testing, okay, let's say you do the testing number one. Okay, when you pull the metal rod or the metal dumbbell shape, you pull and then the metal is increase, and then you stop. Okay, you stop. Okay, it's not reached yet the yield strength or yield point. Okay, when you pull the sample, the measurement constantly increase, and then you stop here. Okay, and then when you release the clamp for in the machine, you can see the metal tend to go back to its original shape. Okay, in this condition we call as a elastic region or elastic properties of the metal. And then again, then when you do the same testing, you will do the same test, okay, towards metal rod or metal dumbbell shape. You pull and then the value exceed the yield strength of that particular metal material, and then you can see the metal start to elongate. Okay, this elongation we call it as a strain hardening process. Okay, what is strain hardening? As I promised, in the next slide I will explain. And then when you pull, and then the metal has reached their limit to hold that kind of force, and then they start to form necking process. Okay, when we see the necking condition on by naked eyes on the sample, you can know already, okay, this one the necking will be formed, and then the this sample can be fractured into two pieces anytime. Okay, and then here from the elastic region, I think you learn in the EBB 113, we can calculate as well the modulus Young. What is the modulus Young? You need to understand. Okay, modulus Young, the value you want to measure the stiffness of the metal itself. Okay, as well, when another other thing is, when you pull a sample and then the sample exceed from point 2 and they continue until point 3, this one we call it as a plastic region. Okay, what's the meaning of elastic and plastic? Okay, I will explain later. All right, so please embed in your mind tensile test. This is a graph, and then there are a lot of information can be extracted from this graph. Okay, this one I don't want to explain more. You can read this kind of explanation. Okay, by the way, I want to explain. Okay, on this graph. Okay, how, let's say you have a new metal, and then you want to check uh, which value of the yield strength for this metal, for this new metal that you found. Okay, if if you cannot get the yield strength value of that particular metal material that you select, what you can do is, okay, after the measurement, okay, after you complete the measurement of the tensile test, and then we can plot the offset 0.02 0.02%. Okay, the offset meaning you need to calculate, you need to identify the exact, how not exact, approximate value of the yield strength for that new metals. Okay, in this case, you need to determine where is the offset. Offset meaning that 0.02% from the strain, and then you need to parallelly extrapolate until you get the point. So that point you refer as a yield strength value. Okay, this explanation you need to read. Okay, this I think I already explained what is the elastic region. Okay, I think I repeat the same thing and again, same as well. Okay, um, okay, in the latter part of my topic, okay, I will I would say stress more how the strain hardening happen. Okay, but as brief, you can see raising the yield strength by permanently straining the material is called strain hardening. This one only by definition. Okay, I think I already explained this. The tensile strength, I also explained about it. For tensile strength, normally the point of the okay, for this kind of phenomena. Okay, this I put something like bright star, maybe something like this. Okay, the tensile strength or UTS is the maximum point. Okay, as you can see, if the material is elastic, you can see this material in this condition. When you pull it into the opposite direction, they still maintain the shape as it is. Okay, but if you exceed the yield strength value here and then move to the end point, okay, you can see the material is start to elongate. Okay, the how I say the area of the sample is reduced, and then the length of the sample in vertical position is become longer. Okay, and then after exceed the UTS value, you can see the necking formation had already started, and then finally the sample is the fracture. Okay, uh, for me in this part, for the stress strain curve, especially for the tensile test, okay, the most important thing you should understand is how to interpret the data. First, how to interpret. Number two, you need to understand how to sketch the diagram, because for the stress strain curve we have the ideal shape of the graph. And then number three is you need to explain, okay, at these stages what happened, at these stages what happened, at these stages what happened. Normally for the stress strain curve, number one, you have the elastic region, meaning that the material can be bounced back to original shape, and then when the sample exceed the yield strength, the sample cannot go back to the original shape but elongate over the time. And then when the sample is exceed the UTS value, meaning that the necking is already started, and then the material is fractured. Okay, in this stress strain curve, you have three stages. Number one is the elastic region. Number two is the plastic region. Number three is the fracture region. Okay, and then for this particular region, they have a different phenomena and different mechanism. Okay, here I share with you. I took this one from the Callister book. Some of the example different type of metal with their yield strength, tensile strength, and ductility as well. Okay, here is the comparison. Okay, between a metal alloy, ceramics, a polymer, and the composite fiber. Okay, as I mentioned in early part of my presentation or videos. Okay, normally metal shows the higher, tensile strength value in comparison with ceramic, polymer, as well the composites. But now, uh, most of the material engineers, okay, try to replace the pure metal with something like the composite materials. Okay, in composite you have a different type of composite, right? You have CMC, you have PMC, you have MMC. What is a PMC? Is polymer metric composite. CMC is ceramics metric composite, and MMC is metal matrix composite. Nowadays, people are moving faster in PMC, polymer matrix composite, meaning that they try to formulate the best formulation in order to produce the polymer composite that can relatively similar tensile strength, even higher. Okay, so that's why in aircraft, in NASA rockets, in Formula One car. Okay, now people are using the polymer based material. Okay, they are developed polymer matrix composite by to reach the properties equal or more than the metal itself. Okay, so okay, here I want to show you two videos. Okay, you need to watch this video carefully. Okay, later you can watch from my slideshow, sorry, from my presentation. Okay, here is the you can see on the top video, you can see how the neckings has been formed. Okay, when it reach its ultimate tensile strength. Okay, so you watch, you see the shape of the metal rod is become smaller, and then you can see the necking has been occurred here and failed. Okay, and then another thing is strain hardening. Okay, for the strain hardening, you can see this video. Okay, in strain hardening, in order to obtain the strain hardening, normally on this, how I say, mm, in strain hardening mode, okay, you can mold or shape that metal into different type of products. Okay, I repeat again. Okay, dalam strain hardening, okay, normally in, let's say, kalau you when you kerja nanti, let's say you kerja dengan Proton ke Volkswagen ke Mercedes Benz ke, they want to uh, design their own engine, own gasket. Okay, gasket, I think. Okay, own engine or own valve. Okay, how they mold it. Okay, how they shape the metal. Okay, of course you cannot shape that metal in the elastic, because when you pull the metal, okay, the metal tend to bounce back into the original shape. So therefore you need to have the strain hardening condition in order for you to add additional process in order to shape or mold the metal. Okay, in this video shows in strain hardening condition. Okay, there is a few method that we can apply in order to shape the metal. In this case, you can see the fogging. Okay, uh, fogging normally is the most popular. Okay, rolling. Okay, when you, okay, let's say in strain hardening mode, when you go through all these processes, okay, for example in rolling, when you do the rolling, the hardness, the, how I say, the density of the metals become increased. How? Okay, that's why you need to find the answer why. Okay, as well, in strain hardening mode, you can extrude as well the metal into different shape. That's why after you exceed the yield strength point of the metal, you can shape the metal into any kind of shapes and design. Okay, therefore, that's why bila you bekerja dengan industri, when you deal with the metal, the yield strength value is really important in order for you to manipulate the condition of the metal. Okay, I think that's end of the session for my first part for the tensile test topic. Later, I will show you another videos. Okay, about how uh, okay, the properties obtained from the tensile test. Okay, I hope you watch this video, and this part is really important because this part contributes a lot of marks for my parts for EBB 344. Okay, that's all from my side. Later I will see you back. Okay, thank you. Bye bye.